already we discuss about this, why we are carried out the test, what is the reason behind it. Okay, and this is the one reaction that is carried out when there is a presence of oxygen, and when there is a in absence of the oxygen, this is the reaction takes place. There is a formation of the carbon dioxide and methane. If it having the oxygen, then there is a formation of the CO2 and H2O, which is the we call it is the end product of it. And obviously there is generation of some new cells and some stable product, which may be the have the sulfate or nitrate and all. Fine. Now about the BOD test. So BOD test, what it is typically, we are trying to find how much oxygen the microorganisms are consumed while decomposing the organic matter, and we are correlate the consumption of the oxygen by the bacteria or by the microorganism is equals to the amount of organic matter present in it, because this organic matter who consume is consumed by the bacteria and the microorganisms. So for that one, they require the oxygen. Where from they get the oxygen? They get the oxygen from that water. Okay, so there is a deflection of the water, because in that BOD water it is a airtight, so we are not externally feel any air, or we take care of it that there should not be air enter into the bottle. So whatever be the initially amount of the DO which is the present, so the same oxygen they are taking place to carry out the reaction. And because of that one, initially we find how much DO is present. So we take a test and find the dissolved oxygen in the BOD in the BOD bottle initially, and then after 3 days or 5 days, there is a 5-day test. So after the 5 days, again we note down what is the DO, and that deflection is nothing but the organic matter which is present. Okay, so this is the simple way. So as it is said, the biochemical oxidation is a slow process and theoretically takes the infinite time. Now, what is the meaning of this one? So if you see the infinite time, why they require the infinite time? Because you don't know whether the whole oxygen is consumed by the bacteria or not, because we put it that bottle into the incubator, and we wait for some 5 days, 7 days, 10 days, maybe required the 20 days too. Okay, so they're having 20 days test too, and from that one we have a certain result. But definitely there is a continuously new organic matter present, new cells are generated, and that may get decomposes. So we don't know exactly when that the oxidation is stopped. Okay, so that's why we call it is a infinite time go to the completion of the reaction for the oxidation of the complete oxidation of the organic matter. So for that one, what we do, as we are not daily we find out how much oxygen is present, how much oxygen is present. So what we do, during the first few days the rate of oxygen depletion is rapid. Now what happened when you perform the experiment and when they analyze the things, at that time they found that first 3 days 5 days with the temperature condition, they found there is a more rapid depletion of the oxygen. More rapidly the organic matter get decomposes, and after some days there may be the slowly decomposition takes place. So what we do, we are taking first 3 days or 5 days for test. So first 5 days how much oxygen is consumed, and that we will say that, because after 5 days what happened, there is a deflection of the oxygen, but that is not that much. Means the organic matter which is decomposed by the microorganisms, the rate of reaction is not that much when it is before the 5 in between the 5 days. Okay, so this is the case. That's why we have the limited time period we are taken out. Okay, and that is the big the reason that we have the maximum the deflection is takes place during the first few days. Okay, and also it is depend on the biodegradable organic matter. What type of the biodegradable organic matter present? What is the initial concentration of the biodegradable organic matter? This is also the important, because I want to give you the one example. Consider that you have 5 grams of organic matter present in 1 liter, and the number of the microorganisms which are present, say only the 5. Now only the 5 microorganisms present, and we have the 5 milligram of the organic matter present in it, and the consumption of that bacteria or the microorganism, say it's only required the 1 milligram as a food. So what happened that only the 5 microorganisms present, you have the 5 gram of the organic matter, and only the 1 milligram is consumed by the each microorganisms. It means only the 5 milligram they can decompose. Why? Because the capacity of that microorganisms, say it is only the 1 milligram. So how much it consume? Only the 5 are present. That's why it is a 5 milligram. What about the remaining one? It as it is, it will not decompose. Even the microorganisms are not taking part or the consuming the oxygen too for decomposition of it. Okay, because after that one they get relaxed. So just like if you have say the what we call the food is very excess and only the limited people are there, so definitely it will not consume all the food by that limited people. Okay, the same thing is happened here. So it is again depend on the rate of reaction is depend on what is the concentration, initial concentration of the organic matter which is present into the water. Okay, that is one of the part. So on that also the rate of reaction is depend, and there is a deflection is carried out. And one thing is that why there is a more degradation is taking place in the initial stage. Okay, because it is easily the food is available for the microorganisms, so they can consume as much as food what they want according to the capacity. They grow the microorganisms in between that days, and again the number of microorganisms are increases after say 2 to 3 days, and then there is a more deflection takes place. Okay, so that is the one of the reason behind it. Okay, so during the last part of the BOD curve, oxygen consumption is mostly associated with the decay. So I will explain that one with the help of the curve which is shown. We call it in 11.11. So if you look at this part, from that one we can easily understood what exactly meaning of it. Okay, so here if you see, say that this is the curve. Okay, it shows the x-axis as a time, y-axis it shows the oxygen consumption and the BOD remaining. So the two the numbers are here. The one is oxygen consumption, how much oxygen is consumed, and the BOD into the water. If you look at this curve, this dashed line, this one dashed line, this is a smooth curve. Okay. If you see, this is the day, day up to the 20 days. They take a test and find what is the amount of BOD present. So they take a test every day for 20 days. Okay. This is what ultimate BOD stands for, the what? Initial amount of the BOD present. Now, BOD is what? It is a biochemical oxygen demand. So initial BOD means what? This is give the concentration of the waste present in it or organic matter present in it. So initially at 0 day. Okay. Now this curve, the dash curve, it shows the BOD suffix T, which is called oxygen exerted. Means how much BOD is what is the value of BOD? BOD value means how much DO is consumed, and on that basis we can say this much amount of the organic matter are decomposes. So this is the line which is show this line, dot line. It is the consumption or decomposition of the organic matter. Fine. And now what is the smooth curve shows? It shows the how much amount of the BOD remaining. It means this much is the decompose and this much is the remaining, which is shown by L suffix T. And these are the formulas. Afterward, we will look about these formulas, because with the help of these formulas, we can can you hear me?
Yes.
Okay, okay, fine. Okay. So this curve, it shows that this smooth line, how much BOD is remaining, and this shows how much BOD is consumed. BOD consumed means the organic matter is consumed. Okay. So this is the value, the consumption of the organic matter, and this is the curve shows the remaining of the organic matter into the wastewater. And if you see, this is the test for the 5 days, and they found that if they maintain the temperature up to the 20 degrees Celsius, okay, the sewage within a 20-day period. So this curve it's give for the 20-day curve, okay, and here it is says that the oxidation of the carbonous organic matter is about 95 to 99 completed. It means if there is 100 milligram of the organic matter present into the 1 liter, then within a 5 days, about 99 milligram of the organic matter is consumed or decomposes with the help of the microorganisms or the bacteria. Are you getting my point? It means within a 5 days, they completed the 99%, and only the 1% is remaining, and that is shown like this one. That's why if you see the curve after that one, it is almost stable. If you see this is how much is the consumed, then almost stable. Here also it is almost stable. The value is not that much, but sharply if you see within a 5 days, okay, this is the 5 days. So you see sharply the BOD is decline, means the remaining amount decline, and sharply the amount of decomposition of the organic matter taking place, because this shows the BOD values, the remaining BOD value, and the how much is the consumption. Consumption means what? The organic matter consumed by the bacteria. Okay, and from that
Yes,
one we can say that because of that one, what we do for our analysis, for our test, we always take a 5 day, and this 5 day we take on the temperature of 20 degrees Celsius. Because again, the reaction, we know that you learn the reaction, chemical reaction engineering. Okay, in the chemical reaction engineering, we know that there are the number of factors which are affecting the rate of reaction. So either it might be the temperature, it might be the pressure, okay, it might be the other things too, okay, whatever the things which is mentioned there. Okay, so here also the temperature is the one of the part which can affect the rate of reaction. Okay, ultimately decomposition means what? It is what we call it is the reaction taking place with the help of the microorganisms, and the oxidation reaction taking place. Okay, the consumption of the oxygen, decomposition of the organic matter with the help of the microorganisms. So we say that the microorganism is what? It is nothing but the one of the catalysts which we added even in chemical reaction. We know that what is the role of catalyst. So here also the microorganisms play a role for decomposition of the organic matter. Okay, and first 5 days it is mentioned. So period is used to BOD determination is 60 to 70% oxidation is completed. It means around 60 to 70% of oxidation is completed within that 5 days. Okay, so 20 degrees Celsius temperature is used as an average temperature value. So we kept the 20 degree Celsius is the temperature where about 95 to 99% of the carbonous organic matter it get decomposes. Okay, at 20 degrees Celsius. Okay, so this curve shows that it is a 5 day test. That's why we always put it here. It is mentioned the biochemical oxygen demand represented by. Okay, so it is what? It is represent a 5 BOD 5. What is this BOD 5? BOD is the biochemical oxygen demand, and this 5 means a time. Timing we always mention in terms of the
days.
days, and that is the 5. Okay, and at 20 degrees Celsius. So this is the meaning, means that the test is carried out for a 5 days at 20 degrees Celsius. Okay, and this will give the indicate the total amount of oxygen consumed for a biochemical oxidation. It means total oxygen consumed for a biochemical oxidation of the organic matter for the 5 days. Okay, even in our countries, if reaction is increased, if we increase the temperature up to the 70 Celsius, for that one we get the about 90 to 95% of the consumption or the decomposition within 3 days. Okay, so what we can, for that we can write it as BOD3 at 27 degrees Celsius. Okay, so it may be the test for the 3 days or 5 days. Most of the times we carried out just for the 5 days. Okay, now this is one of the matters. The temperature is important and the time is important. Okay, because we know that the rate of reaction is depend on temperature as well as time. Now in this case, again, one factor that we have, it is the dilution factor. So what do you mean by dilution factor? And why we need to do, just like I said, if the concentration is much more and you have the very little bit amount of the microorganisms present. For example, 5 gram of the organic matter which is present, and you have only the 5 microorganisms which having the capacity of 1 milligram to decompose per day. It means the total, say the 10 number of 5 number of microorganisms are decomposing only the 5 milligram per day. So for the 5 day, it may have about 25, or some bacteria maybe if it is arise, then almost it is 50 milligram. Why this is happened? Because the number of microorganisms which is present here, it is a less. That's the one case. Second case is what? If there is a high concentration of initial concentration of the microorganisms, in that case what happened? I'm talking about the test. Okay, so in UV water on the 3 milligram is capacity, or say the matter of 5 gram from that concentration, and then you realize that the amount of oxygen which is present in the water is not much more than 9 milligram per liter. It is only 9 milligram per liter. And for decomposition of this 5 gram per liter of organic matter, it may require say say 50 gram per liter, 50 milligram per liter oxygen. Now obviously in that case only the 9.1, and they required much more. So in that case what happened? It is not possible for that to get a oxygen, and then again the what we call, there is the anaerobic reaction taking place, and again the case is reverse. Okay, so for that one what we do, we try to dilute that water, dilute the wastewater. So here it is mentioned the saturation value of DO for water at 20 degrees Celsius is around 9.1 milligram per liter. It means saturation point. After that one, it is not possible to dissolve the oxygen into the water at 20 degrees Celsius. So already you learned that what do you mean by diffusion in the mass transfer. Okay, so how much diffuse? It is only the 9.5. That is the saturation point of it at 20 degrees Celsius. Again, you know that diffusion is again carried out on the different temperature. Whether the temperature increase and decrease, on that basis, the diffusion of the gases taking place into the liquid. Fine. So here what we do, it is usually necessary to dilute the sample to keep the final DO level. So here what we try to do, that it should not be totally consume the oxygen. If it is total consumption, then what happens? There is a reverse reaction taking place. Rather than the aerobic, it is an anaerobic reaction taking place, and formation of the CO2 and the methane, and you will not get how much oxygen is consumed by the bacteria, and you will not get a correct value of the organic matter present in it. Okay, so what is the end point? So the DO should be after the end of the incubation period, it should be around 1. It is initially it is 9.1, and at the end of the incubation period is what? 5-day period, 3-day period is the testing period of. Okay, so that is called an incubation, because we put the into the incubator. So it is around at least meaning around 1.5 milligram per liter. Okay, so that we can say that a certain amount of the oxygen is available for the bacteria, for the microorganism, for the decomposition of the matter. Okay, so that what we do, we use the actually unseeded sample can be worked out as. So the sample we do, we are measuring the initial DO, we measure the final DO, divided by the P. The P stands for the dilution fraction. Now, what is the dilution fraction is what? It is the volume of wastewater upon the volume of wastewater plus the volume dilution water. Initially, we take the volume of water, say the 10 ml, you are taking the volume of wastewater. So 10 ml plus the dilution, you are diluted with the 100 ml. So it is 30, 10 plus 100, it is 110. So what is the fraction of it? It is 10 divided by 110. That will be the dilution fraction. And that dilution fraction you have to take here to get the corrected BOD sample. Okay, what exactly the BOD is there. So here what we do, the total volume of BOD bottle is used to the 300 ml, already I said. The dilution of the water is aerated for sufficient time for the correct DO close to the saturation value, as I said. So there should not be a total consumption of the DO or the oxygen from it. Otherwise, in between, say you test for the 5 days, and within a 2 days, all the oxygen which is present in the BOD bottle, it is consumed by the bacteria. Now what happened? As there is no sufficient amount of the oxygen present, then the decay of this microorganism takes place. There is a dead bodies of that microorganisms present in the water, and you will not get exactly how much is depleted because there is no oxygen. So you are not saying initially 9.1 and now it is 0. So 9.1 equals to the 9.1 milligram of the per liter is the organic matter present, because that is the relation. But already maybe in between the 2 or 3 days, all the oxygen consumed, and because of that, what happened? As there is no oxygen present, so bacteria get killed, it get dead, okay, and the sum of the organic matter may till there is present, but just because of the unavailability of the oxygen, it is not decomposes. Okay, so that's why we always do a dilution for conducting the test. Fine, are you getting my point? Now in this case, what we do, first we are diluting the water. Okay, dilution of the water is taking place. Then we have to put certain nutrients and the buffer solution into the BOD bottle. Now what is the role of nutrients and the buffer as we are doing a test? Okay, and for that microorganisms, some of the nutrients is required at the initial stage. Okay, so that is we required, and some buffer solution is required for the growth of the microorganisms. Okay, for the growth of the microorganisms. Otherwise, what happens? Just like we know that when there is a small kid, for the small kid we give a good type of food which he tastes, the taste of the food is good, and he can just take that food happily. Okay, the same thing, nutrients that we are provided at the initial phase of the growth of the microorganisms. Okay, so that they start to grow and then they decompose it. Okay, so they are not directly given the food to the organic matter which is available. So we give some nutrients food, and then after consumption of the nutrients food, they again attack or they try on organic food too, which is present in the wastewater. Okay, so for that one, we always put it the nutrients and buffer solution are added to the dilution of the water. Okay, so as it is mentioned, provide the nutrient for the bacterial growth and maintain the pH. Buffer solution is for maintaining the pH. Sufficient amount of the seed is added to the BOD bottle to ensure the adequate concentration of the bacterial population to carry out the biodegradation. So what is this nutrients and buffer? We call this is the seed. Okay, we add the seed, means extra organic matter we are adding into that bottle. Now because of that, what happened initially, if say the 5 milligram per liter organic matter present concentration, and you add again the 1 milligram per liter there, because of that, what happens, we are adding extra organic matter in it. But when you are taking when you take a test and measurement, that time what happened, already it is present and you add the extra. So you have to, whatever the extra that you add, you need to remove it. You need to subtract that part. And for that one, there is a calculation. So here, usually the 1 to 2 ml of the sewage per liter is considered as a sufficient act as a seed. Okay, so 1 to 2 ml sewage that we always add per liter in it, and in that case, that is the sufficient for that one. And when we are noting the what is the value of BOD, okay, with the seeded sample, then we have the formula this one. What is the initially formula of BOD5? If you see here, this is the value of BOD. What? Initial DO minus final there. DO is what? Dissolved oxygen. I is represent the initial. Minus DO, F is represent the final. P is represent the dilution factor. Now initially we have this formula, but just because we are adding the seed solution in it, the seed in it, so our formula get changed, and now accurately if you want to know the what is the value of BOD, then we have this formula which is already mentioned, DOI minus DOF divided by P, P is the dilution fraction, minus BI minus BF into 1 minus P. What is this B? B stands for what? A dissolved oxygen of a blank. Means dissolved oxygen of a blank, initial and final values. So this is the initial and final values. Okay. P is represent what? It is the dilution factor. So it is the what? V and VW by VM, volume of wastewater in mixture upon the total volume of a mixture. Okay. So that will give exactly what is the value of BOD present in it. Okay, so this is the formula. You always remember this one, no problem. It's the easy one. For the accuracy, we have to put it this one to get the exact value of it. Okay, so this is DO drop in blank is multiplied by the 1 minus P, because this volume of blank is only present in a sample. Okay, because we are putting this seeded sample into it, that's why we are minusing that part. Okay. Now there is one example. Obviously, we will take that one in the next lecture about it. What is that? The example is given the dilution of the water requirement. So here it is mentioned the wastewater is expected to have BOD5. BOD5 means 5 days of about 200 milligram per liter. The initial DO of the dilution water is 8. Calculate the dilution requirement for the BOD determination. Okay, so we will solve that one. As we have the formula, then we try to solve it. So what is mentioned? A wastewater is expected to have BOD5 of about 200 milligram per liter. Means the value of BOD after the 5 days, it having the 200 milligram per liter. Okay, the initial dissolved oxygen is 8 milligram per liter. Means DOI, how much? It is 8 milligram per liter. Now here we need to calculate the dilution requirement for the BOD determination. We need to find what is the dilution. Okay. So for that one, so let's see the formula. Can you capture this or you just write it? Okay. Note down this for numerical. Okay. Have you noted down?
सर थांबा जरा.
Okay.
सर झालं.
So here, first we note down what is the data is mentioned in the numerical. We have the formula I just show you the formula and that one can easily understood. One formula is one. Okay. So if you want to know what is the value of BOD, one we should know what is the dissolved oxygen initially and dissolved oxygen. So dissolved oxygen you get when you have the sample, you put it that sample into the BOD bottle, bottle with the proper dilution, and you know down what is the DO. So let's say DO you got it is 8 milligram per liter because that is mentioned. So initial DO is 8 milligram. Then what happened after 5 days? We remove the take out that bottle and again we check how much is the DO present. That will be the final. So initial minus final BOD. How much the BOD is there? Because we know that there is a relation, direct relation. The dissolved oxygen deflected is equals to the amount of organic matter decomposes or organic matter present. Directly we say organic matter present. Okay, and this is the one factor that we have when we are putting the seed solution in it, and from that one we get, and P is the dilution that we know. This is one formula. This is the another formula. Okay, initially as we have the limited data, as we have the data which is mentioned BOD sample. Okay, the DO initially we know that we don't know the DO final, and we try to find this one, how much times it is needed. Okay, now what we know that the maximum concentration of the DO is 9.1, and for the incubation we say required 1.5 up to the 1.5. Okay, 1.5 to 2. So here in this case what we do, here we try to get the dilution required. Okay, it means the BOD is equals to the DOI minus DOF divided by the P, and P stands for the dilution fraction. Okay, so what we do, we consider the final DO is 2 milligram per liter, or you can consider 1.5 milligram per liter, no problem, because they said that up to the 1.5 as it is mentioned, the dilution for the 5 days we always took it, it is around 2.5 2.0 milligram per liter. As it is not mentioned in this problem, that's why we are assuming this final DO. Okay, so this lets us the final DO is maximum, it is 2.0 milligram, is 2 milligram per liter is there. So we use the last formula to get the values. Okay, so you just take this formula. Okay, so first you just write down this part. Okay, yes, you just note down this one. BOD is 200 milligram per liter, DOI is 8 milligram per liter. Minimum DO that should be left after 5 days of incubation is around 1.5 to 2 milligram per liter. So here we are taking the 2 milligram. So DOF is 2 milligram. Just note down that.
Yes.
Okay. After that, write down the formula from which we have to calculate the what is the value of P. So you know this formula, this one.
आवाज ब्रेक होता है जरा
What was that?
सर
Okay. You just again repeat this one. You write this formula for the equation of this DOE of sample equals to DOI minus DOF of P. Okay, is it okay?
हो सर झालं.
Fine. After that, calculate how much value that you is it 33? So we just divide 200 divided by 6.
Sir, same येते 33.33.
33.33.
Yes. Okay, fine. So we say that around 35 to 40 to 40 times we need to dilute that solution. Okay, because the condition is what minimum DO that should be is around 1.5 to 2. Okay, and for that case, what we do, we need to dilute this one. The solution which is given to you is around 30 times. Okay, so this is one numerical based on this one, how the dilution of the dilution water requirement. The another is this is another numerical. You just take a snap of it and solve it. Okay. And it is mentioned a test bottle containing only seeded dilution water has its DO level drop by 1 milligram per liter in 5-day incubation. 300 ml BOD bottle filled with the 110 ml of wastewater rest seeded dilution water experience a DO drop of 6.2 milligram per liter in the same time period. What would be the 5-day BOD of the wastewater? Okay. Now this is the second numerical is based on the what we take the
POD
last
drop
formula.
emission.
Yes. Have you captured this one?
Done, sir.
Okay. And you use this formula to calculate. Okay. So this formula. Take a snap of this.
झालं, sir.
Okay. And also for the calculation of the P, you require this formula. This one. Okay. You take the snap of this also.
झालं, sir.
Yes,
So
sir.
you just remember this one. Obviously, in this directly they give the answer too, but you just calculate and you just write it. What is the mention here, and accordingly you calculate how much is the BOD after 5 days. Fine.
Yes, sir.
Okay. Now I stop here, and we will continue the remaining part in the next lectures. Okay, as I think on Monday or something. Okay, fine.
Yes, sir.
Any problem
Thank
too?
you, sir.
Okay. Any
No,
new?
sir.
Okay, fine. Okay, now you can leave the meeting. Thank you.
Bye, sir.
Okay, bye.